boys and girls. It's Miss Messina from Team Cortland again.
Hi, boys and girls. It's Mrs. Viola from Team Geneseo.
Hi, everybody. It's Mrs. Cabrera from Team Stony Brook.
Hi, everybody. It's Mrs. Levin from Team Purchase.
Hi, guys. It's Miss Hidalgo from Team Geneseo.
Hi, everyone. It's Mrs. Schwartz from Team Cortland.
So, boys and girls, I hope you really enjoyed doing our lab activity this week with the penny.
So first, let's look back at the results from our penny reactions experiment this week. Did all of the pennies change in the same way? What do you think has happened to these pennies? And why did some react differently to the liquid that they were placed in compared to others?
Hi, boys and girls. So from what pennies I started with and for what pennies I ended up with, the water and soap pennies appear the same. They really don't have much change in their composition, whereas the vinegar, lemon, and soda look very much different from what I started from.
This was our introduction to chemical and physical changes. For today, we want to do a little bit of a review with you. So we're going to go through a little PowerPoint, and it's called Chemical and Physical Changes. And here we go. So let's talk about what a physical change is. A physical change is a change in a substance that does not change what the substance is. So let me give you some examples of a physical change. So some examples can include a change in shape, a change in size, or a change in your state of matter. What about melting from a solid to a liquid, or boiling from a liquid to a gas, or evaporation from a liquid to a gas, or condensation from a gas to a liquid, or freezing? If we freeze water, it goes from a liquid to a solid. These are all some examples of physical changes. A physical change can be caused by grinding, cutting, crushing, bending, breaking, heating, cooling, swishing. All of those things can cause a physical change when something actually just looks different.
To continue on physical change, some evidence that makes a physical change occur might be a change in its shape. Maybe it gets smaller or it gets larger. Maybe a change in its form, a change in its size, like if you have a piece of paper that's flat and then you crumble it up, it gets smaller, but it's still paper. A change in the phase. This is always a physical change, like when you're taking an ice cube and you're melting it and it goes from a solid ice cube to liquid water. Physical changes are usually reversible. So the paper that's crumpled up and is smaller, we can flatten it out and make it bigger, and it's still paper. So here's some good examples. So what could you do to these items to cause a physical change to occur? Let's think about that.
For the ice cube, you could probably melt it so it goes from a solid to a liquid. For the cookie and the orange, you could probably break those into smaller pieces.
Boys and girls, a chemical change is a change in which the substance is changed into a new, different substance. You change what it actually is. For example, you see the marshmallow burning there. Burning is an example of a chemical change. Examples of chemical changes include burning, rusting. Rust is a totally different substance, a new substance than the metal it started with. Tarnishing, decomposing. Those are all some examples.
Chemical changes occur when a chemical reaction causes the bonds between atoms to break or form. So a physical change, if you have water, which is two H's and an O, and it goes from a solid to a liquid, it's still two H's and an O. That's a physical change. A chemical change occurs when the bonds between the atoms break or join together with other atoms. the evidence, you have to look for evidence of chemical changes. That means there's something new that was there that wasn't before. So evidence that a chemical change has occurred might include a change in color, a change in odor or different smell, a formation of a precipitate, which is a solid that comes out of the liquid. So if you pour it in the top beaker, you pour in the clear liquid into the other clear liquid, and look what happens. There's that yellow stuff is forming. That's an evidence of a chemical change. If gas is formed and gas comes out of the substance, like bubbles, or there's changes in their physical properties, like the density we learned about was a physical property. Color is a physical property. So if you just tear a piece of paper in half, you still have two pieces of paper. It hasn't changed. If you burn paper, what do you have? Then you have a bunch of ash and heat and light.
Physical and chemical change. During a chemical change, energy can be released in the form of heat, like you're seeing here with the picture of the fire, or in the form of light. Also important to remember is that when a chemical change occurs, energy can either be released or absorbed.
Okay, let's practice. Let's review what we've learned. So we're going to be looking to see if we see a chemical reaction, which means a chemical change is occurring, or is it just a physical change, which means a chemical reaction has not occurred. So here we're looking at a picture of fireworks. What type of reaction is most likely occurring here? Is it a physical change or a chemical change? And then how do you know?
The fireworks are an example of a chemical change because they release not only heat but light when they explode in the night sky.
Okay, here we see a picture of an egg cooking. What type of reaction is most likely occurring here? Again, it will be a chemical change if we see a new substance being formed, or a physical change if it is the same as the original egg before it was cooked. So here we see an egg, and the egg white is cooked, and also the yolk is cooked inside, which means that heat was applied to the egg. The egg now is both chemically different and physically different than the original raw egg. That would make it a chemical change. Mm-hmm. Here we see an ice cube. The ice cube is melting. The ice cube as a solid is solid H2O, water. The melted ice cube is now liquid water, which makes it liquid H2O. What type of reaction is most likely occurring here? Is that a physical change or a chemical change?
This would be a physical change because the ice cube is changing form from a solid to a liquid.